NASA recently issued a thought-provoking statement about Pluto, suggesting that this distant dwarf planet might not be what we once believed. This comment appears to hint at recent discoveries made by the New Horizons spacecraft, which revealed unusual phenomena occurring on Pluto's surface. Among the most striking images is one showing an object seemingly floating across Pluto's terrain. This raises intriguing questions. Could there be some form of unknown life on Pluto, or are we witnessing a peculiar geological phenomenon? Despite its small size, Pluto holds significant mysteries and surprises. When its planetary status was revoked in 2006, scientists were unaware of the groundbreaking data that New Horizons would later provide after reaching Pluto 9 years later. These revelations challenged earlier assumptions about the icy world. Why Pluto lost its planetary status? Pluto was reclassified as a dwarf planet because it shares its orbit with other objects in the Kuiper belt, failing to meet one of the criteria required to be a planet: a clear orbital path. This reclassification caused widespread disappointment, as many people had grown up considering Pluto the 9th planet in our solar system. The decision sparked protests from the public, prominent scientists, and even governments. Despite its demotion, Pluto continued to capture hearts, especially when New Horizons sent back its first images in 2015, revealing a striking heart-shaped feature on its surface. A new perspective on Pluto. The first detailed images of Pluto stunned the world. For decades, depictions of Pluto in textbooks and on classroom posters were artistic guesses. Even the Hubble Space Telescope couldn't provide a clear view of its surface. However, New Horizons offered a close-up look at this enigmatic world, revealing a vibrant, dynamic landscape filled with glaciers, canyons, and smooth, icy plains. Far from the barren, crater-filled wasteland scientists expected, Pluto turned out to be a lively, complex planet. Its surface showed evidence of ongoing geological activity, which was entirely unexpected. It took years for the data from New Horizons to reach Earth, but each new discovery painted a picture of a world far more dynamic and intriguing than previously imagined. The floating ice and mysterious terrain. One of the most puzzling findings from New Horizons was the appearance of an object that seemed to float across Pluto's surface. The image, which gained significant attention in 2016, showed what looked like a human-like figure walking across a honeycomb-shaped snowfield. In reality, scientists believe the object to be a massive nitrogen ice glacier. This so-called wandering mountain, likely formed from nitrogen and methane ice, pushed upwards by geological processes from beneath Pluto's surface. These peculiar formations suggest that Pluto may have a warm interior. The possibility of a subsurface reservoir of nitrogen ice supports the idea that geological activity is ongoing, potentially driven by heat in the planet's core. This warmth could indicate the presence of liquid pockets resembling subsurface oceans or even magma chambers. Such findings challenge earlier notions of Pluto as a completely frozen, lifeless world. Pluto's surprising climate and seasonal changes. The New Horizons mission also revealed unexpected details about Pluto's atmosphere and seasonal variations. Pluto's thin atmosphere, composed mainly of nitrogen, methane, and carbon monoxide, undergoes dramatic changes depending on its distance from the Sun. Unlike Earth's snow, which forms from water, Pluto's snow consists of frozen nitrogen and methane. When Pluto is closer to the Sun, this snow sublimates, turning directly from solid to gas, reshaping the surface and driving additional geological activity. These findings highlight that Pluto is far from a static, frozen world. Its surface is constantly evolving, influenced by seasonal cycles and its eccentric orbit. A living world in the Kuiper belt. Pluto's dynamic landscapes, floating ice, and evolving atmosphere suggest that it is far more alive than previously thought. The possibility of a subsurface ocean, geological activity, and even the potential for extreme forms of life make Pluto an exciting subject for future exploration. The discoveries by New Horizons have turned this distant dwarf planet into one of the most intriguing objects in our solar system. While Pluto may no longer hold the title of a full-fledged planet, it remains a captivating and dynamic world with stories to tell. The little planet with a big heart continues to surprise and inspire scientists and the public alike, leaving us eager to uncover more of its mysteries. Far from being a barren, icy wasteland, Pluto has continually amazed scientists with its breathtaking landscapes, active geology, and peculiar climate phenomena. Once thought to be a cold, cratered no-man's land, Pluto has revealed itself as a dynamic world of massive ice formations, deep canyons, and smooth frozen plains. Ice landscapes and geology. Since the New Horizons mission provided groundbreaking data, Pluto's surface has revealed stunning insights. A remarkable image from 2016 appeared to show a figure walking across a honeycomb-shaped snowfield. These formations, though they resemble terrestrial ice, are composed of nitrogen and methane. The walking figure turned out to be a dirty chunk of solid nitrogen floating across the icy expanse. This discovery hints at a nitrogen reservoir beneath Pluto's surface, which pushes solid blocks upward, forming honeycomb patterns. Such activity suggests the presence of a warm interior and previously underestimated geological processes. This warmth might even mean the existence of liquid pockets resembling subsurface oceans or slushy reservoirs of nitrogen or magma-like ice. William McKinnon, head of the New Horizons geology team, compared Pluto's interior to a glowing ember, with PC simulations showing that these features have evolved over millions of years and remain active even today. Processes like sublimation, where solid substances transition directly to a gas, play a crucial role. The extreme temperatures on Pluto create mysterious geological cycles, keeping the planet alive with motion. Snowfalls on Pluto. The concept of Christmas in the snow on Pluto might sound bizarre, but it's real. Pluto experiences snowfalls made of frozen nitrogen and methane, unlike Earth's water-based snow. As Pluto orbits the distant Kuiper belt, it undergoes dramatic seasonal changes due to its eccentric orbit and axial tilt. When Pluto is closer to the Sun, its thin atmosphere of nitrogen, methane, and carbon monoxide warms slightly, causing it to expand. As it moves farther from the Sun, the atmosphere freezes and condenses, falling to the surface as exotic snow. These processes refresh the landscape, covering it with new deposits and driving geological changes like glacial flows and potentially even cryovolcanism. These atmospheric cycles influence surface brightness and create dynamic landscapes. Pluto's mountains, composed of water ice, are unusually mobile, reshaping the planet's surface in ways unlike Earth. Sputnik Planitia. The heart of Pluto. Pluto's iconic heart, officially named Sputnik Planitia, is one of its most fascinating regions. Stretching across 1,000 kilometers, this bright, nearly flawless ice plain consists primarily of nitrogen ice mixed with frozen methane and carbon monoxide. It contrasts sharply with the darker, more rugged terrain surrounding it. Geologically, Sputnik Planitia is a vast impact basin likely transformed by cryovolcanic activity. Unlike Earth's volcanoes, which erupt molten rock, Pluto's cryovolcanoes release slushy, icy materials. Heat from Pluto's interior causes nitrogen and other volatile substances to rise and freeze on the surface, creating unique formations. Sputnik Planitia's smooth, level surface suggests ongoing renewal through convection within the ice sheet. Researchers believe a subsurface ocean of liquid water might exist beneath the plain, kept fluid by Pluto's internal heat. While the possibility of life in this hidden ocean remains speculative, it cannot be entirely ruled out. Charon, Pluto's companion. Many may not realize that Pluto has its own moon, and not just one. Charon, Pluto's largest moon, was discovered in 1978. Measuring approximately 1,212 kilometers in diameter, Charon is so large that it forms a binary system with Pluto. The two bodies orbit a common center of gravity located outside Pluto itself. Some scientists suggest Charon is not merely a moon but a dwarf planet gravitationally bound to Pluto. This unique pairing significantly impacts both bodies. The gravitational interaction between Pluto and Charon creates tidal forces that affect their surfaces and possibly their internal structures. These forces could explain Pluto's warm interior and ongoing geological activity. Charon's gravitational influence also affects Pluto's rotation, with both bodies locked in a mutual tidal embrace, always showing the same face to one another. Interestingly, Charon may interact with Pluto's atmosphere, capturing ejected atmospheric particles and forming a temporary, thin veil of gases around itself. A dynamic world beyond expectations. Pluto, once considered a lifeless rock, has proven to be a place of wonder. Its icy landscapes, atmospheric phenomena, and unique geology challenge our understanding of distant celestial bodies. Thanks to the New Horizons mission, Pluto's mysteries continue to unfold, revealing a world as complex and dynamic as it is far away. When Pluto is closest to the Sun, its thin atmosphere heats up slightly, causing it to expand and rise. However, as Pluto moves away from the Sun, the atmosphere cools and condenses, sinking back to the surface. This dynamic creates a fascinating phenomenon. When Pluto's atmosphere condenses, it can effectively snow, with flakes composed of nitrogen and methane. The variations in surface brightness and the distribution of icy deposits suggest that nearly all of Pluto's surface features and landscapes are influenced by these atmospheric cycles. Interestingly, Pluto's mountains are not made of rock but ice, which behaves uniquely in this environment. As a result, Pluto's entire surface undergoes more movement than Earth's, driven by these atmospheric changes. One of Pluto's most iconic features is its heart-shaped region, known as Sputnik Planitia. Far from being merely a visually appealing mark, this region is among the most intriguing on the dwarf planet. Named after Sputnik 1, the first artificial satellite launched by the Soviet Union in 1957, this vast ice plain spans approximately 1,000 kilometers and consists primarily of nitrogen ice, with traces of frozen methane and carbon monoxide. The smooth, bright surface of Sputnik Planitia contrasts sharply with the darker, more complex terrain surrounding it. Geologically, this region likely originated from an impact event, later reshaped by cryovolcanic activity. Unlike typical volcanic activity on Earth, where molten rock erupts from below the surface, cryovolcanism on Pluto involves the emergence of cold materials such as nitrogen from the planet's interior. This process forms the unique structures observed on Pluto's surface. Sputnik Planitia's remarkably flat terrain suggests it is regularly renewed through internal processes. Scientists theorize that convection currents within the ice sheet continuously reshape the surface. Additionally, there may be a subsurface ocean beneath Sputnik Planitia, kept in a liquid state by Pluto's internal heat. While the possibility of life in such an ocean is speculative, it cannot be entirely ruled out. Pluto's largest moon, Charon, also plays a crucial role in shaping its parent body. Discovered in 1978, Charon measures about 1,212 kilometers in diameter, making it so large relative to Pluto that the two form a binary system. They orbit a common center of gravity located outside Pluto itself. This unique gravitational interaction creates tidal forces that affect both bodies, influencing their surfaces and possibly their internal structures. These forces may contribute to Pluto's geologic activity and internal heat. Charon's influence extends beyond gravitational effects. The Moon may capture atmospheric particles escaping from Pluto, briefly surrounding itself with a tenuous mantle of shared materials. Despite lacking a permanent atmosphere of its own, Charon's interaction with Pluto adds another layer of complexity to this dynamic system. NASA's findings from the New Horizons mission have challenged long-held perceptions of Pluto. The mission revealed a world far more active and diverse than previously imagined. One particularly intriguing discovery was an object on Pluto's surface that appeared to float, sparking speculation about whether an unknown geological phenomenon, or even a form of life, could exist on this distant world. Pluto's reclassification as a dwarf planet in 2006 remains a topic of controversy. The decision, prompted by the discovery of numerous small planets in the Kuiper belt, required astronomers to redefine what constitutes a planet. While Pluto meets some of the criteria, such as being round, it shares its orbit with other objects, excluding it from the list of major planets. This decision has led to widespread debate and efforts to reinstate Pluto's planetary status. Since its discovery in 1930, Pluto has captured the imagination of scientists and the public alike. The New Horizons mission provided the first clear images of Pluto, offering a detailed glimpse of its colorful, dynamic, and heart-shaped surface. These images revealed a complex world with a range of landscapes and phenomena, showcasing Pluto as a far more active and vibrant entity than previously believed.